Hello friends, now we are going to talk about the another kind of the experiment, that is active filters. Filters, it filters out something, segregates some wanted signal from the unwanted signal, right? Or else it allows a certain and it discriminates the unwanted or the which is not required one. Okay, is a kind of the and what kind we are trying to select over here, that is nothing but the frequency selection we are going to do over here. So this is a frequency selective circuit, and that passes a specified band means the something certain range of the frequency. Okay, or else the certain range of the frequency can be blocked. Okay, or else sometimes the certain in between the certain band is allowed, and above which it will be uh, stopped, and below which also the it gets stopped. So that is also the kind of the band filter. Okay, now actually means there are certain different ways of classifying the filters, that is the analog or the digital filters, passive or active filters, and audio or audio frequency filters, or else the radio frequency filters we can have. So in case of the analog filters are designed to process the analog signals, while the uh, filters processes analog signals using the digital techniques. Okay, digital techniques for the some kind of the processing it is used. Depending upon the type of the element we used for the construction of the filters, can be classified as it can have the kind of the analog filters, or else the what we can say is the digital filters, or else we can have the passive filters or the active filter. In case of the passive filters, what kind of the components we use? RCL. Generally the passive elements will be used for the construction of the filters. On the other hand, active filters, in addition with this RLC, we can use a transistor or the operational amplifier for building of the such a type of the filters, that is a active filter. So in this experiment we are going to use the active filters, okay, by means operational amplifier, and the R and C as a passive elements. Okay, now the type of the element we use dictates the operating frequency range is RC filter. Okay, so generally these are known as the RC type of the filters. R and C are, because R and C decides the how much amount of the frequency can be allowed or the passed. Okay, so now these active filters are the most extensively used in the field of the communication, okay, and the signal processing. So actually they employed in one form or the another almost all electronic system, that is even radio, television, and even or space satellites, biomedicals, telephone sectors, and so on. So many places it is used. Now uh, actually they are the different kinds: active low pass filters, high pass filters, band pass filters, band reject filters. Reject also, no, just like it can allow, it doesn't allow as well, it can reject as well. Or else all pass filters, all the frequencies of the certain ranges can be allowed to pass, right. So in case of the low pass filters, what happens that it allows the low frequencies to be passed, and the higher frequency will be reached. It means the uh, output signal, or the whatever the output signal we are getting it, it will be passed, or its amplitude goes on remain same. Okay, it goes on remain constant. Okay, and after a certain frequency it starts decreasing, it start decreasing, right. So this is something like we call it as a low pass filter. Low frequency will be allowed to pass, and the high frequency signal will be rejected, means its amplitude goes on decreasing one. Okay, the corresponding this circuitry is used over here. You can see over here R and C, R and C. So the when we are trying to give is the input signal, so the for the each cycle or each frequency, the capacitor gets charged, and what we can have, that frequency will be allowed. When the capacitor gets fully charged, then certain after that this signal will not be allowed to pass, or after a certain range or after certain value it is then allowed to charge. So yeah, that signal will be stopped. Okay. So, it output signal will be diminishes, because this ratio or the rate at which the decreases the amplitude or the gain of the this operational amplifier, the filter, decides whether it is a first order active low pass filter or the second order, so on and so forth. So, this is what we are going to see in this kind of the low pass filter. So, if now this uh, in case of the high pass filter, it just only the simple change is there. Instead of the capacitor is grounded, if we just change the positions of the or interchange the positions of the R and C, it becomes a high pass filter. Okay. It becomes a high pass filter, and we will get the lower values of the frequency will be stopped, and the higher frequencies of the frequency band will be allowed to pass. Okay. So, now in case of the low pass filter, there will be the highest cutoff frequency, that is FH will be given by 1 over 2 pi R C. Okay. R and C decides the frequency, how much it can maximum frequency can be passed, okay, or below which all the frequencies will pass, above which it will not be allowed to pass. On the other hand, in case of the high pass filter, again the RC time constant only decides the cutoff frequency, and this is a lower cutoff frequency, means below which the all the frequencies will be stopped, that is FL is equal to 1 over 2 pi RC again, right. So, the gain can be calculated by just gain is nothing but the output voltage upon input voltage, and we can calculate the logarithm of 10 times logarithm of the gain will give us the gain in the decibel. Okay. So, this is what we are just going to talk about in this whole experiment. Now, I will just try to switch to the circuit board. Okay. Now, okay, I have already made the connections. Okay. So, this is something like an active filter. Okay. I just try to say tell you the connections. Okay. And see, now here is the signal generator. Okay. Do remember, this is signal generator, sine wave I have selected. Okay. You can see over here is a sine wave input, just like square wave, here is a sine wave inputs are given. Okay. Sine wave, red is positive, this is negative for the sake of understanding the ground, and then the 3 volt is selected and the certain frequency ranges are there. Okay. Now, this is what we are having the low pass filter. This is the operational amplifier. To work the operational amplifier or make it active, we should have the plus minus 12 and the ground has to be connected to the ground. Okay. Then, according to the circuit diagram is over here. Okay. Or else I can make it this. Okay. So, this inverting terminal is connected to the feedback, through the feedback. Okay. It is connected. So, this is line from 2, it is going to the feedback. RC, okay, R is here. So, it is given to the input, as well as we will need to see understand the what type of the signal it is there on the CRO. So, these two lines are for the CRO. Okay. So, it is connected on the CRO of the first channel. Okay. Then, what we can have here, R and C, these are connected. Okay. R and C are connected and it is given to the non-inverting terminal. So, R and C are connected, this capacitor is connected to the non-inverting terminal. Okay. And then capacitor is grounded. So, this is grounded one, and output will be taken. Okay. This is the output on the CRO. Okay. The wire is connected to the CRO over here. Okay. So, this is input signal to understand the what type of the signal we have used, and then this is output signal. So, I am just turning on the all the circuitries. All right. Now, what we are expecting here is something like I am just trying to give us the press the 100 frequency, and I can vary its frequency, right. I can vary its frequency. It is given over here, input is given over here, and you can see the signal over here, right. it is a signal corresponding to it. Now, I can just tune the parameters, I can tune the parameters that you will be able to understand it. Now, you can see now, if I make it the both on the same scale bar, then it will go out of the scale. So, I just make it on the other hand. Okay, this is the, so this is the input signal and this is output signal. Okay. So, here I am just trying to change the frequency, I am trying to change the frequency, then see what is happening actually. Okay. I am just changing the frequency. Input signal amplitude remains same, but the output signal amplitude has diminished, right. Now, I am going to decrease the frequency. Now, see, amplitude has increased, there are distortions coming because of the frequency ranges has been different one. Okay. Instead of that, if I just make it here, okay, yeah, it would be better otherwise, right. Now, this is the signal. Now, you see this is a lower frequencies and I am just trying to make it increase the frequency, it remains same and start here decreasing, it started decreasing, and after a certain frequency range, okay, I make it stable one, just changing the time per divisions knob, right, and you see it is decreasing and suddenly it has, I have changed the range for 1K 2K. So, it has diminished almost its output signal. Okay, I just make it happen to be something like this. So, this is for the all about the low pass filter. Okay. Now, these are the connections actually for the high pass filter. I have made the low pass filter as a high pass filter. How? You can see these are the similar kind of the connections over here, but now if we just interchange the positions of the R and C, we can make it to the high pass filter. Now, what we have? Yeah, we have just the only changes of the position of the R and C, okay, interchanged over here. So, what we can have? This position, this resistance has to be here and input should be given over here, and R this has to be here and it has to be the grounded one. What I made it? Okay, I have given the input to the capacitor and the one end of the resistor is grounded one, okay, according to the our diagram. Okay. So, resistance is grounded and input is given to the capacitor, and this combined is given to the non-inverting amplifier. So, the whole thing is same. So, now you can see the response of this amplifier on the CRO. Now, what we can see here? Now, you can see the signal on the CRO, okay, and now what I can have? I am just trying to decrease the frequency, obviously the output wave, okay. So, this is actually the output wave, downside is the output wave, okay, and it is getting diminished, but if I just turning on, making it on, I will just make it the same signal, okay. So, you will be understood. If I make this on this same scale, then you will be understand the what is happening over there. Okay. If I just going to increase the input frequency, obviously its output signal also getting increased, or amplitude of the output signal is getting increased. Right. I am just trying to change the time per division so that the signal will not get fluctuated one. Okay. So, you can see now this is earlier 1K signal was there, but I am just changing the frequency in the 1K range, and this output signal will remain same now throughout, even if I just increase the voltage after certain. Okay. I just make the signal more clear so that you would be understood. And even if I just change in the 1K, there are some distortions. Even if I just make it very high frequency, then it is not working actually, but is in the 10K. So, almost 20K around, around like that, it is just working over here. Because at higher frequency more distortions are there, so we are not able to understand it what is happening, but in the 1K range it is easily understandable. Okay, in 1K range you will be able to understand. Okay, so this is on the 5 times, and this is on 2 times, so do remember it. This is high pass filter, and both are low pass and high pass filter we have covered.